In 2010, a sophisticated computer worm known as Stuxnet surfaced, profoundly altering the domain of cybersecurity. Diverging from conventional malware focused on data exfiltration, Stuxnet functioned as a cyber weapon engineered to disrupt physical systems. It specifically targeted Iran's Natanz nuclear enrichment facility, impeding their uranium processing capabilities for several years. This operation was not the endeavor of an isolated actor, but a coordinated state-level initiative. In this analysis, we shall examine its mechanisms and elucidate essential concepts such as zero-day exploits, undisclosed vulnerabilities in software, and programmable logic controllers, or PLCs, devices that orchestrate industrial machinery, prompting deeper exploration of these topics. Stuxnet was initially identified by cybersecurity analysts in Belarus upon its infiltration of a system under their purview. Propagation occurred via removable USB devices, exploiting vulnerabilities within the Windows operating system, akin to concealed entry points. This circumvented air gapping, a security measure isolating networks from external connectivity. Upon ingress, it employed a rootkit, a stealth mechanism for malware concealment, rendering it undetectable to conventional defenses, evoking the notion of an imperceptible intruder within the infrastructure. Technically, Stuxnet incorporated 4 zero-day exploits, previously unknown software flaws leveraged prior to remediation. These included manipulations of Windows LNK's shortcut handling and print spooler services. It achieved privilege escalation, elevating access rights systematically. Additionally, it compromised Siemens Step 7 engineering software integral to industrial controls. This facilitated penetration into PLCs, the programmable logic controllers governing automated processes such as mechanical actuators. Within the facility, Stuxnet lay dormant until detecting designated centrifuges, high-speed rotors employed for uranium isotope separation. It selectively targeted units equipped with frequency converters from specific manufacturers. Under nominal conditions, these operate at consistent rotational frequencies. However, Stuxnet induced extreme oscillations, accelerating rotors to overdrive before abrupt deceleration, precipitating mechanical failure analogous to catastrophic engine overload. Concurrently with the sabotage, Stuxnet manipulated monitoring interfaces to display fictitious operational data, masking the anomalies from personnel. This constituted a man-in-the-middle interception, wherein the malware interposed itself between sensors and displays, substituting authentic readings with fabricated ones. Concealment was further enhanced by appropriated digital certificates, cryptographic endorsements akin to forged credentials, and the integrated rootkit. Globally, its code affected hundreds of thousands of systems, yet the physical destruction remained concentrated within Iranian assets. The consequences were tangible: damage to roughly 1,000 centrifuges and a deferral of Iran's enrichment timeline by an estimated 1 to 2 years. Attribution, while complex, strongly indicates a collaborative operation between United States and Israeli agencies under the programmatic name Olympic Games. Regrettably, the malware later proliferated beyond controlled confines, entering the public domain and serving as a technical template for subsequent cyber armaments. Stuxnet underscored the capacity for software to inflict physical harm and inaugurated a new era of cyber-physical conflict. It demonstrated the fallibility of assumed defenses, air gaps, trust in vendor certificates, and perimeter security, and elevated zero-day exploits to instruments of strategic disruption. The lessons are clear. Critical infrastructure requires vigilant protection through rapid patching, robust network segmentation, continuous anomaly detection, and adoption of a zero-trust posture that presumes compromise. Vigilance and resilient design are the defensive pillars against future cyber-physical incursions. This concludes our examination of Stuxnet, a seminal event where digital code inflicted physical harm, heralding modern cyber conflicts. Should you appreciate this fusion of historical narrative and technical insight, designed to stimulate further inquiry, please like and subscribe to the Cyber Nomad for additional content of this caliber. Until next time.